Between 2010 and 2019, astrophysicists discovered more in the vastness of the universe than ever before. Many discoveries that Albert Einstein had already predicted are considered sensational. We are at the beginning of the golden age of astronomy. This is what quite a few scientists and researchers currently claim. If you would like to leave Earth with us to travel to the farthest reaches of the cosmos, then show us with a thumbs up, subscribe to Simply Space, and look forward to the videos that will be waiting for you in the future. Let's begin the journey. Strange cosmic echoes from the universe. Are there echoes bouncing around in space that might carry information? The oldest light in the universe spans more than 13 billion years. The photons of this light originate from the time of the Big Bang. The plasma created by this Big Bang cooled and became transparent. The photons of this time do indeed carry information about the state of the early universe, but they are becoming weaker and weaker. Currently, they form a cosmic background of microwaves. A sea of low radiation is penetrating the universe. A team of researchers has put together a test. They wanted to find out how this information could be transported. The scientists imagined someone sending a message into the future through a series of echoes from the early universe. To do this fictitious messenger used the coding of a string of 0 and 1. These echoes travel slower than light without fading. Therefore, the echoes are able to transport more information than photons over long distance. Martin Martinez's team of researchers thus wanted to prove how an intelligent being can use this phenomenon to transmit much more information than a mere radio signal. The probability of such contact by intelligent extraterrestrials from the distant past is naturally low. But the principle of looking for these echoes in this way could be worthwhile for cosmologists. Information about background signals from the early universe is also spread by this echo. It is important to find out exactly what shape the echoes will take. This, and how to build the receivers that can pick up the echoes, is a major challenge. Avi Loeb, who works at Harvard University, says it's an interesting idea, but still quite theoretical. The researchers and authors would have to give concrete examples of their observations to have an impact. 13 wandering black holes have been sighted not far from Earth. Astronomers identified 13 massive wandering black holes in dwarf galaxies of the universe. At the moment, many of these same astronomers are talking about the discovery of more wandering monsters. In a published article for the Astrophysical Journal, Amy Rines of Montana State University and colleagues of the U.S. National Radio Astronomy Observatory gave details. These black holes would be less than 1 billion light-years away from Earth. They were discovered in galaxies 100 times more massive than our own Milky Way. They're among the smallest known black holes. Their average mass is about 400,000 times that of our Sun. According to the researcher Rines, half of these 13 black holes are not located in the center of the galaxy as usual. It would also show, in accordance with computer simulations, that these galaxies merged with other galaxies early on, and that about 50% of the black holes will migrate to the outskirts of their galaxies. What is meant by galactic cannibalism? In 2003, renowned astronomers Roger Guatakita of UCSC and David Reitzel of UCLA gained new insights into a process known as galactic cannibalism. They discovered large spiral galaxies that grew by devouring smaller satellite galaxies. Their proof was in a faint trail of stars in the nearby Andromeda galaxy. These stars are probably a huge trail of debris, a remnant of an ancient fusion of Andromeda with another, smaller galaxy. This process, in which a large galaxy merges with a companion galaxy by gravitational interaction of tides, and a larger galaxy is formed, is called galactic cannibalism. Some galaxies could be observed during different phases of the merging process. They seemed to be in the process of cannibalization. However, this is not a galactic collision in which the galaxies retain most of their original shape. All of these processes are in line with the latest galaxy models from astronomers and various space agencies such as NASA. It is assumed that galaxies grow because they pick up mini halos of dark matter in their surroundings and dwarf galaxies. If dwarf galaxies get too close to the enormous halos of the so-called host galaxy, they can be torn apart by the gravitational tidal forces. And that leaves behind stellar streams. They are the relics and main evidence of the original event, which are said to currently exist beyond their boundaries between the Milky Way and the large and small Magellanic Clouds. The evidence is based on gravitationally attracted hydrogen streams flowing from these dwarf galaxies into the Milky Way. A collision of our galaxy with the nearby Andromeda galaxy could have catastrophic consequences and is even likely one day. A black hole ejected a star from the Milky Way. A recently discovered star with the name S5-HVS1 is currently located about 29,000 light-years away from our Earth. The star shot out of the center of our galaxy at a blinding speed of 4 million miles per hour. It is currently traversing the constellation Grus or Crane in the southern sky and is heading for the depths of intergalactic space. The team of astronomers, led by Ting Li from the Carnegie Observatories, used a telescope in Australia for a study. It became known as the Southern Stellar Stream Spectroscopic Survey, or S5. The star is about twice as massive as our own Sun and 10 times as bright. Astronomers tracked the star back to its galactic center, home to a black hole known as Sagittarius A star, a gravitational monster with the mass of 4 million suns. It is believed that this star, which had escaped from the black hole, was once part of a binary star system. When the system came too close to the black hole, a star fell in and one was hurled away at hyperspeed. This three-body gravitational dance took place 5 million years ago, and the star will have completely left the Milky Way in 100 million years, Dr. Mir and her team say. The hyper-fast star races 10 times faster than most stars and twice as fast as most fastballs, or speeders, or speeding stars, at more than 1,000 kilometers per second. Dark matter. Almost 100 years ago, there were the first indications of the existence of dark matter. The Swiss astronomer Fritz Zwicky studied the movements of galaxies in a galaxy cluster called Coma. However, the movements were much too fast. Visible matter such as dust, gas, and stars could not hold on to the galaxy cluster with their gravity. That's why this phenomenon was explained by the assumption that there are large amounts of invisible masses, which must also be responsible for the cohesion among the celestial bodies. The mass in the galaxy cluster of a distant galaxy produces the distortion of the light in the foreground. The distribution of this mass can be determined from the distortion. There is a difference between certain mass and observed matter, aka gravitational lens. However, the existence of dark matter has not yet been proven. Dark matter is apparently only revealed through its own gravitational interaction with conventional matter. The dynamics of galaxy clusters, together with the gravitational lensing effect, cannot be explained by visual matter alone, if recognized laws of gravity are applied. The largest black hole in the universe. The largest black hole ever discovered and measured has the size of about 66% of all stars in our Milky Way, or 40 billion times the mass of our Sun. It lies in the elliptical galaxy Holm 15A. This supermassive galaxy was formed from at least 8 colliding smaller galaxies. Holm 15A lies in the center of the galaxy cluster known as Abell 85. With a snapshot of the stars in Holm 15A, a model was created. The stars are in the orbit of the galaxy around the black hole. Using the model, scientists calculated the mass of this black hole and published it in the Astrophysical Journal. The God particles, Higgs boson. In 2013, Robert Brout, François Englert, and Peter Higgs received the Nobel Prize in Physics. In 1964, they announced a completely new principle, the Higgs mechanism. It was intended to explain the mass of elementary particles. The discovery of a new particle in June 2012 substantiated their idea. It completed the standard model of particle physics. In this model, all visible matter in the universe is attributed to only 12 elementary particles, the first pillar of their model. 3 forces form the second pillar. These are the electromagnetic, the strong, and the weak force. These 3 forces are also transmitted by particles. This means there are particles in matter and also particles in the forces. The force carriers have an intrinsic angular momentum with the value 1, while the particles of matter have an intrinsic angular momentum of half of this value. Thus, all matter particles and their interactions could be measured exactly with particle accelerators. However, the important third pillar was discovered after a long time, the Higgs boson particle. Higgs and his 2 colleagues redefined the property mass. For this, they named a field, Higgs field. It fills the entire space. All mass-affected elementary particles are slowed down to a certain extent when they interact with this field. The apparent mass increases the stronger they are coupled to the field. In the end, the calculations yielded decisive results. This Higgs field must be tied to the newly discovered Higgs boson particle. The space we know today is several billion times larger than when the universe was born. As the cosmos expands, the research of astrophysicists will also become more and more extensive. In the future, a new generation of researchers and instruments will uncover many more mysteries in the infinite vastness of the universe. And again, these discoveries will raise completely new questions. If you want to share your experience on this topic, please leave a comment. See you next time.